Hi, everybody. Welcome to another episode of Observe It. I'm your host, Daniela, and I'm super excited today to welcome my friend Alex to the show. Alex, over to you to do an intro, please.
Thank you, Daniela. My name is Alex Kehlenbeck. Daniela was actually my first manager, I think, for a little while at a company called Lightstep that I joined that she was working at. That was in the observability space. So that was how we met some years ago, 4 or 5 years ago. But it's a space I've been working in for a super long time at Google before Lightstep and a whole bunch of other things that maybe we'll get into. But I'm super excited to be here and talk about it. Thank you for inviting me.
Yeah, of course. I'm super excited to pick your brain on the subject. Um, let's kick it off with a very general question. What is your view of the current state of observability in the industry right now?
Yeah, is it bad if I say it's a mess? I don't know. I feel like I should be more of a cheerleader given that I work in this space. But I was talking to somebody secondhand who had moved from observability into security, and I look at security and I say, man, that industry seems very complicated to me from the outsider. I know nothing about security. And they said, no, actually, compared to observability, it's so easy. The customer needs are straightforward. Like we can understand what product, and this blew my mind, and that this person could say that. About those two industries. But maybe I think it's more a statement about observability and the kind of mess in that space more than a comment about simplicity of security. Um, I don't know. I mean, it's I've worked in the space for a long time, providing. I built internal tools at Google for a very long time, and now I'm building tools as a vendor for paying customers to use. But of course, also through that time, I've been a user myself of observability tools. We use what we build, and we run big systems, and we rely on the tools to help us run those systems. I do think things are getting better, but it's just so fragmented, technology wise, protocol wise. And I would also say that in a lot of ways that no vendor has cracked the kind of usability product nut. I think it takes a lot of time investment by customers, no matter what vendor they're using, to get their observability up and going and to understand what it is that they're doing and seeing with it. Um, so that's a bummer. I hope that we can do better as an industry, as vendors. But yeah, it's complicated right now, I would say.
Yeah, for sure. And actually, part of the motivation for me starting this, first as a reason to kind of reconnect with people in my network to talk about a very interesting subject, but mainly the motivation is to talk, speak to people who aren't always paying attention to the observability space, because I think we can get in an echo chamber where it's not as complex as it may seem to somebody from the outside whose core job is not to build in the observability.
Absolutely,
um,
absolutely.
so I start with a question that I get asked a lot that I'm not even sure I have a good answer for, but a lot of people come to me, with their whatever billing, with their bills from the observability. Let's talk about metrics first, right? And they're like, why is metrics cardinality such a big deal? Why do I have to go and play whack-a-mole with my system with which tags or labels or whatever you call it attribute? Why does that matter? Why can't metrics support high cardinality?
Yeah, hi, this is a great question, and an example of kind of the class of challenges I think that people face. I think I'm gonna give a couple of answers maybe. Um, there's maybe a historical answer is the place to start. The first monitoring system, we didn't even call it observability back then, that I was involved in. We started building at Google, and I don't know, 2008 or something like that. Um, and the systems of that era, including ours, but also others, Gorilla at Facebook and some others that I know, a little bit about from having talked to folks. A lot of those systems, they they had sort of, for a variety of reasons, they had a requirement that they store a lot of their recent data in memory. It was for kind of dependency reasons and availability reasons. Um, Circular dependency reasons. They didn't want to depend, at least our system at Google didn't want to depend on the cluster file systems because those teams wanted to use us to monitor their stuff. And so data landed in memory. And I think when you build a metric system like that, there's a tendency to have just enough internal state about each unique time series that if your customer comes along and spams you, sends you a lot of distinct metric attributes, combinations of attributes that generate a lot of distinct time series. That tends to be kind of an adversarial workload for a lot of those systems, at least systems of that era.
Because it blows up the memory, is that
Blows it too much memory. It's sort of not a, so you can solve it in some cases by making the system big and expensive. And I think that's what you see with some vendors, especially some of the early vendors in this space. Who I didn't work for them, but I suspect that maybe they had systems that behaved in a similar way. You can use a lot of cardinality with Datadog or one of the other big vendors. You just have to pay for it. So I think it's not necessarily that it can't be done, but that in those kinds of systems, that style of architecture, it tends to be fairly expensive, and so you end up getting whacked for it. That's a historical answer. I don't think it needs to be like that. I think we've come a long way in the last 10, 12, 15 years. And I think that a lot of the innovation, for example, that's happened in the OLAP space, the analytical processing space, with column storage and other kinds of databases built around that sort of data, a lot of things have been learned in that space that have kind of are only slowly being applied to the observability space. I mean, you never heard anybody say, let me give an example. If you go to your logging company, for example, right, they're going to charge you based on bytes typically, often, but they're not going to hit you with a bigger bill because you happen to use these tags instead of those tags, right? It's a different architecture, it's a different style. In some cases, they have more experience dealing with these problems. So I don't think it's a fundamental technology problem that we can't have high cardinality, but I do think that, for sort of historical reasons, that some systems in the monitoring space don't handle that workload very well today.
okay? So let me make sure I understand this correctly. You're saying that if I add a bunch of tags, which I all deem, very useful to myself, and those tags have a certain level of cardinality. If I add all of them on the same metric, there is like a combinatorial explosion, number of time series, because for each unique value on that tag, it produces a unique time series with every single other combination of tags, right? So it's a combination. It's a multiple factor, and that adds to the total number of uh, time series, total number of bytes that has to be supported.
Well, yeah, it's the total number of bytes and the total number of bytes that need to be supported just because you happen to have a lot
That's
of,
right. That's great.
unique time series. You're probably still sending, an 8-byte float and a, 8-byte timestamp. Each one of your points is the same size, but you've spread them out potentially across many more times, distinct unique time series. Yeah.
That's correct. But to me, like that's a volume storage cost, right? Which I think when we think about a lot of the billing and the pricing models of observability vendors, the slope of the price, like how fast that price scales, just seems uncanny compared to what I would imagine the storage cost scales, right? So that's what I have trouble reconciling or explaining to others when they ask me, well, I know it's sending more data, but do I really have to pay, 10x more because of carbon?
Yeah. And a funny thing, you probably don't want to hear this as a customer. I know you're a customer of some of these vendors. Just speaking hypothetically here. A funny thing has happened. I think it's hard to sell into this customer base in some cases, right? They get set in their ways. They understand what it is they're doing with one vendor, and if you're a new vendor trying to sell to them, they often have trouble kind of getting a foothold. And a funny thing has happened more than once with Lightstep, where um, we tried to sell to some customers based on units other than the number of time series they had, other than cardinality. We said, let's just count how many bytes you send us, and you can spread those bytes out however you want across the time series that you want. We kind of tried. This is not how we sell it today, but we tried that with a couple of customers at one point, and they got really confused. Even though it would have worked out, we thought, to their benefit, they understood cardinality as a unit of size from having worked with previous vendors, and they kept saying to us, "Well, but we don't understand. We don't know how many bytes we send. We don't know how we're going to spread it out. We don't. That's not a unit that we know how to think about." So even though we thought we were giving them something appealing, an appealing pricing model, it just kind of confused them, and we ended up kind of not shipping that pricing model, and instead we sell cardinality like everybody else, even though our particular system, doesn't scale particularly badly that way. We're forced to sell and price in a way that fits with the market, even though our system doesn't. It's kind of a bummer. But
Interesting. So what you're saying is that the underlying technology, like you said, is not really the direct cause of this increase in price, especially the slope with which it increases. But people are so used to the fact that cardinality is a pricing lever, that as a business you kind of have to conform to the industry standards, because it's easier to reason about.
yeah, and I'm optimistic. There's enough smaller players in observability now that are all saying just, I mean, everybody has identified cost as an angle that maybe they can use to try to get a foothold. So I'm optimistic that, somebody's going to make it work, right? I mean, I hope it's us, but I really hope it's somebody. And so I think in 5 years, 10 years, it won't be like that, but it's slow to changing things. It's very, very difficult to kind of move the mindset of a market, especially a kind of enterprisey market that, as I said, gets set in its ways.
Yeah, it's funny you say that because I just recently had another guest on the show, a friend of mine in the observability space, founding a new company, who said the exact same thing about disrupting the pricing model and sort of anchoring around. He's also anchoring around the idea of storage of bytes, right? Of like, okay, well, what is the lowest margin? Like, what is my cost of just storing raw bytes on the cloud? If you look at something like Google Cloud Storage or Amazon S3, and then on top of that, what is the value I provide as an observability vendor? It ought to not be 200x more expensive
Yeah,
to store.
right.
Um,
Great.
so I'm curious then of the technology that you're speaking of, right? So tell me a little bit more about the underlying storage system that you've built in the past to support whether it's time series or traces or logs. Um,
Yeah. So one of the as I mentioned earlier, some of the systems in the OLAP space, the analytical processing space, that have embraced a lot of kind of columnar storage ideas and columnar processing ideas in the last 10 years. I mean, there's it's they're all over. It's Dremel and ClickHouse and I mean, there's everybody's doing it these days, right? Um, shouldn't say Dremel, so just BigQuery is what I mean. Um, we've managed to apply some of those ideas and techniques to our storage system at Lightstep and have kind of hence changed the equation a little bit, right? We're much more sensitive to just the aggregate number of bytes that get sent to us. There is some dependency on cardinality, but is far, far lower than I don't think it would concern you if you knew the details, right? And that we like that. It's been very appealing. I think it was kind of a good choice that we made, and we've been kind of happy with how that piece of the storage system has worked out. It's required a lot of engineering, right? I mean, you can't just kind of slap a different storage system underneath your product and hope that everything is going to work exactly right. So we've had to do a lot of engineering to make it work. But that's kind of the core piece, is that we borrowed a bunch of those analytical processing ideas and carried them over. And so our database looks a lot more like that than like an OLTP, a kind of transaction processing sort of store, which again, historically, I think is what a little more like what these systems looked like 10, 15 years ago.
and was your objective anchored mostly on cost or something else like performance or both?
Yeah, some of both. Very much cost, although you often you get some performance out of it too. Um, at least after you've done some engineering to make it fast, right? Um, the performance is an interesting question. I didn't mention everybody cares about cardinality for cost reasons. I think that's the first kind of shock that they get. It can also matter in some systems, many systems, for query performance, right? It is in many systems simpler to if you've got 1,000 time series that you're aggregating, that's kind of fundamentally often going to be cheaper than if you're aggregating the same number of points across a million or a billion time series, right? So there is a performance angle, but again, I think with kind of the right engineering and borrowing some of these columnar, processing ideas, um, you can make that penalty, pretty small, and make your queries pretty performant, even if you're looking at a whole bunch of data, a lot of cardinality. So
So do you use the same underlying storage system across the different observability primitives, metrics, logs, traces?
Lightstep happens to, I'm sorry, I keep saying Lightstep. We got acquired by ServiceNow. I should say ServiceNow Cloud Observability. That's what they pay me to say, but I'm going to keep saying Lightstep. It's shorter. We do for metrics and for our tracing data. We use the same technology. It's kind of the same storage engine, and to a great extent the same query engine. Our logging product is a little bit different. It came through an acquisition, although spiritually it's not dissimilar. So the code base is quite different, although some of the ideas are quite similar. But we do for traces and metrics, and it actually, I don't know how many of your listeners have ever played around with a demo of Lightstep, but it enables a number of neat things. So for our tracing data, our span data, we actually are able to do what look like extremely high cardinality queries and aggregations over that data. We can kind of derive and execute things that look like metric queries. We can draw squiggly lines and graphs and so forth. But that's backed in many cases by the span data. And if you look at a pile of span data, the cardinality is bananas, right? I mean, every single span essentially has a unique combination of tags because it has, at least at the very least, because it has a span ID on it or some unique identifier that makes it unique. If you squint at it and say, that doesn't look like metric data, it sort of does, except you have a gazillion time series with a single value for each one, right? It's kind of the worst case. But we managed to use the same storage and query serving technology to serve that data, which I think is that was when I started believing that we had done things right, was when we were able to start serving those queries against that, worst case cardinality span data.
Yeah, that's really cool. And then, so I guess what I'm not understanding then is it sounds like high cardinality at the span level has not been a problem, or is not as much of a problem as one might find it inside metrics. How's that possible? Like, what makes the difference there?
I would say it looks, the system ends up looking for that data a lot more like what a BigQuery or something like that looks like. We've kind of it's different in all the details, but spiritually it looks like something where we're trying to construct or synthesize things that look like columns per attribute, and then we can execute queries across those, the subset of columns that you ask for in a particular query, right? That's kind of the magic for trying to make the queries fast. You say, okay, if you do a span query and you ask for all of the attributes back, well, that's not going to work, right? Everything is genuinely unique. Your result set will be huge, but nobody does that. People ask for narrow slices or group bys that aggregate over narrow small subsets of the columns of the attributes, and that turns out you can make fast.
Makes sense. So then I imagine this can be applied forward as well with logs. If you can apply some, structure or schema to the log.
We hope so. Yeah.
And then, so then what is the relationship, in your opinion, sort of between metrics, traces, logs, right? Like when a lay developer, like I'm completely naive about observability, and I come to you and say, Alex, how do I utilize these three in my program? What do you say?
Well, I think there is and will probably always be a big difference at the instrumentation level, right? The little bit of instrumentation you have to write in your own program to emit a log probably will always look a little bit different than to emit a metric or a trace, right? And there's some convergence, and OTel's trying to do some of that, but I think do a little bit of thinking always there. But on the kind of side of using an observability product, I hope that over time those distinctions erode, and that you have you as a customer, you as a user, have more of an ability to kind of state the question that you want answered, and the system will say, well, okay, I'm going to serve that to you using the span data, or I'm going to serve that to you using the metrics data or the log data. For example, a lot of the kinds of questions that people want to answer with trace data or log data often end up having the form of please extract a number. Maybe it's the latency from a span, or maybe it's the count of something that's buried in a log message. Please extract a number from each span or each event, and then draw me a thing that looks like a metric query based on those numbers. A lot of queries and a lot of use cases are solved by that. Not every single one, but a lot of them. And so that kind of experience, I think, can be done pretty well, where the user just has to say, I want a time series, I want a squiggly line, I want a histogram. And I don't really care that you're deriving that from span data or deriving that from log data, or whether you're getting that directly from existing metric data. Just do that. And I think that Lightstep has made some steps in that direction. I think some other vendors have made some steps in that direction also. But I hope it's somewhere that collectively the industry goes towards more for the sake of the users.
Yeah, for sure. I mean, I've been a big proponent of tracing um, ever since I learned about it. I'm actually wearing my "Tracing is Fun" shirt.
Yes, it is.
Very
It is.
very
Well done.
topical today. But the pace of adoption really, hasn't been optimal in my opinion. I think a lot of it comes down to just, inertia, and the lack of understanding at the instrumentation level and at the utilization, in terms of having good products that surface the right information to users, at the right time. So then I guess, as we wrap up, kind of, what would be your advice for getting started and in the space, right? Like I said, again, lay developer, like I heard Alex say that it's good to like get to know tracing and spans a little bit better. Where do I start?
It's a good question. Depending on what language you're in, I think that a lot of what's going on in OTel and open telemetry, so open telemetry is, and I mean, longtime listeners will know probably that open telemetry is a giant open source effort to standardize a lot of the instrumentation pane. Um, you know, kind of a batteries included answer to a lot of the instrumentation troubles that people tend to have. If you're working in a language or with technology that has good open telemetry compatibility, and there's a few languages, Java is one, that are kind of out ahead of the others in terms of maturity, it's a great place to start. And a lot of things will be handled for you. You know, if you're not that lucky, and you're working, in a language or with a tech stack that is less well supported, you've got a little bit of trouble ahead of you. And I would say the best thing to do would be to just keep it simple and don't try to do too much and let some of the tooling catch up to you. To get your counters, emit your logs, and see how far you can get with those, and then go from there. If you happen to be in one of those languages, I wish there were a better answer, but that's what I got.
No, I mean, I think that makes a lot of sense. It actually speaks to, you don't know this, but you actually basically described our stack, right? Like everything that we have in things like Go and Java and Python is OLTel, and we really embrace it there. And our critical data plane is all written in Rust, for performance reasons, and that's a little less developed, in the OLTel space. So we're having to really just keep it simple, and the amount of tracing that we do there is very limited. It's exactly.
Sorry, someday.
No, no, I mean, I think it's good. A lot of it is just, spearheading and pioneering some of this early work as well, in the open source community. So I think, Oldtel's doing good work. A lot of challenging tasks, but very good work.
Yes.
Well, it's been a blast. I had a lot of fun, learned a lot from you. So thanks a lot, Alex.
Likewise. Thank you very much for having me.
And see you next time, everybody.